This also can, the things that affect the analog and digital inputs and outputs is the analog digital converters, which is the ADC, and pulse width modulation. Size, although sizes will not contribute to the functionality of the board or the functionality of the system, it can contribute to the placement of where the microcontroller board will be placed on the system. And it can affect the wiring and things of that nature. The last contributing factor that will determine what microcontroller board we would use would be familiarity. If you ask anyone if they had to, if they had the choice of using something that they were familiar with in software or hardware sense, then they would obviously choose something that they were more familiar with, and they would want to work with that particular subject. When talking about familiarity, obviously the HCS12 and NS12 family will be familiar for everyone, and it has had ECU 383 here at the University of Alabama. And we experimented with the Dragon 12 Plus board. All of these boards have the characteristics which we would need in a microcontroller board to have a valid system, that would validize our microcontroller board for the system. Next is the Arduino family. This family of boards, as you can see, is very small compared to a quarter. You can fit an Arduino board almost in the palm of your hand. These also have the characteristics which we were wanting to have when looking for a microcontroller board. Setting our metric. Our metric for the system is to have a self-contained power system. We'd also want to keep our battery above 30% charge capacity at all times. And then finally, we would want to be able to use more usable power than what a solar panel would be able to produce without the physical tracking capabilities that ours would possess. Validating our whole entire system, we'll start with component testing. Being able to test our components to see if they would meet their product specifications it will affect our subsystem testing. We could do this by inputting or outputting artificial data, such as applying a variable DC voltage supply to our DC to DC converter to make sure that it would operate under its product specifications. Next is subsystem testing. Being able to mesh all these components together will validize our subsystem testing. Next is integration testing. Being able to integrate all of these subsystems together and making sure that they meet their credentials and operate successfully with one another and be able to communicate back and forth with one another is very important. We would mesh, for instance, we would mesh power management computing, and then electromechanical computing, and finally power management electromechanical. Finally, system testing, we would integrate all these subsystems to one another and test the functionality of the whole entire system. We do this artificially again by just one variable that is our sun. We could produce a light for instance, a light in a dark room and validize that our system was operational in the sense that it would be able to implement the flow chart on slide 10 or implement the system and also implement the system in the flow chart on slide 11 and making sure that we meet our metric. Next is Sean Reams, which will discuss the timeline cost of the project.
This is the timeline for the semester. Unfortunately, it's a small picture. There is a larger version on page 1 of the addendum. These are some proposed budgets. We were allotted $500 from the department. We had a private donation of $250, giving us a total allotment of $750. And these are best and worst case scenarios. Best case, we have approximated at $350, and then worst case, we have approximated at $750. And now I'll hand it off to Nathan for economical impacts.
Our societal economic and political impacts, some of the pros are less dependence on oil, coal, and nuclear sources, as well as they can be in government incentive programs like tax credits and educational grants. Some of the cons are it can be an eyesore, as well as it is a high initial cost. Environmental impacts include renewable clean energy that can be implemented in remote regions of the world, and that can be used for disaster relief. However, some of the cons is it can kill wildlife due to shading, as well as there are electronic and production waste, including cadmium, selenium, gallium arsenide, just to name a few. Ethical health and safety concerns include risk from broken glass, metal, and pinching injuries. And anytime you deal with power, there's always the risk of electrical shock. However, it should also help reduce the CO2 emissions. Here are some of our references. And do y'all have any questions?
How would you plan to control the speed and position without a controller in the brush DC motor?
Well, you can implement position and speed by using 3 different types of objects. You can use optical, hall sensor, or back EMF. And with the optical sensor, you actually implement a mechanical device on the back side of the motor with slots or magnets. And the magnets are the hall sensors, but if your slots, you can put photodiodes that can, when it rotates, it calculates a frequency which gives you a velocity. Since the brush DC motor, the voltage is proportional to speed, you could apply voltage, a larger voltage, and increase the frequency of the light sensor. Back EMF is a little bit more complicated because that's when the motor's under load, one side of the motor will float while the other side is grounded, and at that point it becomes a generator, and you can actually measure that back EMF. Any other questions? Billy.
Did y'all ever consider just having it instead of using a microcontroller, just having a logic circuit that solves the problem instead of, if there's more voltage on one side, send, the current that way, or was it out of your project statement?
You mean like using 2 solar panels and determining which one, something like that?
Yeah, so it could find it that way.
I think the only problem is we're going to try to do it with 1 solar panel, but that is a good option that we have looked into, and we still may even consider in the future if we acquire a second solar panel. But you can do that where you can have 2 solar panels and determine which one of them is achieving the most power, and then rotate in that direction until they're both equivalent to each other. That is a very good option, though. Any more questions?
Yeah, how do you know how far to sweep when you're doing the sweeping of the solar panels? Like, how do you know the range that you sweep the solar panels?
This is going to take future testing, but the sun, by some lab experiments, the sun moves about 30 degrees every 2 hours, which is about 15 degrees every hour. And we haven't decided yet exactly how often we want to reorientate our panel, because it does consume power to do so, and we don't want to waste power constantly moving it unless the gain from moving it is going to be enough. So in the future, we will determine that, but if we do it every hour, it won't be any more than about 15 degrees to find the maximum power point. If we did it every 2 hours, it may be worth the wait, but then we'd have to swing it a lot more, and we'll have to do future testing to determine that. Any other questions?
Yeah, you guys were talking about having a servo motor as your best option, but you said that it was like high torque and high speed. Are you really going to be moving this panel that fast?
No, we will not. It's our best option because it has the most control capabilities because of the feedback loop. But we're still discussing the complete options right now. But yeah, a servo would have the most controller usability.
Okay. Yep. We also may want to go fast depending on the application. If, for instance, this was sitting on top of a movable vehicle and it needed to track the sun quickly, it could do so with the light sensors, and it may need to be able to respond quickly, so it doesn't lose where the sun is at a certain given time. Any other questions?
Dr. Riggs?
You're on your budget slide number 35.
Yes, sir.
You have a best case and a worst case. Can you tell me what goes into making it a best case and a worst case? I mean, in other words, you start with the best case, do you just add a fudge factor to everything to get the worst case, or exactly what's the worst case based upon what's the best case? based upon?
Well, in the motors in general, motor prices can range from starting with the cheapest is stepper motors and RC servos. Those can start anywhere around $15 to $20, and we'll need multiples of those. But it's a little fudged because we still haven't decided on what parts we picked, so we range them a little bit.
So best case is the cheapest motor, worst case is the most expensive motor?
Yes, sir.
All right, how about for batteries, chargers, circuit boards, etc.?
It's pretty much the same case all the way. Some other options are too. We're looking into getting some donations of material for the frame, but we're still working on that.
Because maybe I missed it, but I don't remember you telling me different options for batteries and chargers, so I'm a little confused as to how you have, oh, okay, I'm sorry, I did miss it, it's on slide 20, Mr. McCoy gave me 3 different battery options. Okay, so I missed that, makes sense.
Okay. Any other questions? We have time.
1 or 2 more questions at most.
Taylor.
What are you building your frame out of? Wood or metal or?
We haven't quite decided that. Michael can actually answer that. He's done some research on materials.
We do have a product list of all the different metals and materials we can use. At this point, Nucor Steel may be donating us some raw steel to use, and if that's the case, we'll obviously go that route. If that's not the case, we'll, if our budget allows us to, we're going to try to use carbon steel and just coat it with a non-corrosive or rust-resistant material, spray paint maybe, something like that. And if our budget does not allow that, we'll use wood. There you go.
Any other questions? Time for 1 more, please.
Yes.
Why not aluminum?
It's expensive. The price that I've looked into, I don't think that's going to be within our budget unless we can get a donation for that.
Okay.
But it is a good material to use for environmental conditions.
Okay, please thank our group.
They followed all the questions for what. I'll tell you what, that question answer question way better than like he said, yeah.
Joseph was like, "You'll make it Betty to come." And I was like,
He sent us, we told him repeatedly.
We had to go get him. We had to go
He
get
sent us
him.
an email saying, you might need to knock on my door. Like, we're not going to be there 5 minutes. I'm not your damn patient. He has a class.